All right, in this video, I'm going to solve the AMSA Advanced Math Skills Assessment, the Algebra and Functions Sample Test over here. Now, I'm going to do this one without a calculator, but when you're actually writing the test, you might be allowed to use a calculator for some, not all of the questions, and a little calculator icon will pop up if you're doing the exam on the computer. But I'm going to just solve all of these without a calculator, at least if they're possible. Some of them might require a calculator, but let's go through them and see which ones will and will not require a calculator. So let's start with the first question here, which is just function notation. It gives us an equation, g of x equals to 3 times x plus 8, and then find the value of g of 12. So to find g of 12, I'm simply subbing in x as 12 in this equation. So 3 times 12 plus 8, which is 3 times 20, which is 60. So the right answer is part D. Second question, they give us a linear equation here. Which of the following is an equation of the line that passes through the point 0, 0 and is perpendicular to the line shown above? So we know our equation is always y equals mx plus b. I need to figure out the equation of this line over here. Now, the line over here is perpendicular to this line. So I want to calculate the slope of this line over here. To find the slope of this line, I want to do my rise over my run. Now they only give us these two exact points over here. You want to be careful because that's not an exact point. That's definitely not an exact point. That's not an exact point. These are the only two exact points you can use in this question. So I'm going to find my slope over here. You can either do rise over run, or you could do y2 minus y1 over x2 minus x1. I'm just going to do rise over run because it's a bit easier. So my run, which is the distance from here to here in terms of the x values, is 1, 2, 3, 4, 5. And my rise is going down by 1, 2, 3, 4. So my rise is -4. So basically the slope of this line is -4 over 5, which means that the slope of the perpendicular line to this one is basically the negative reciprocal of this. So it's going to change into positive from negative. And I'm going to do the reciprocal, which means flip this upside down. So y equals to 5 over 4x plus b. Now I just have to find the y-intercept. I know that this line here passes through the point 0, 0, and any line that passes through the point 0, 0, basically this line looks something approximately like that. I know that the y-intercept is definitely 0. It's passing through the point 0, 0. So my b value is just a 0, which means that my equation is just y equals to 5 over 4 x, which is part A. Third question, they give us a rectangular prism. Say the surface area can be found by using the sum of the areas of each face of the prism. What is the surface area of the prism with these dimensions? So to find the surface area, you just want to do the front times the back. So the area of the front is just 9 times 3, which is 27. And then because the back has the exact same area as the front, I'm just going to times this by 2. So that's 54. And then we'll do the area of the left side and the right side. So the right side here is 4 by 3, which is 12. And then I can just times this by 2 for the left side, which is 24. And then we'll just do the top and the bottom. So the area of the top, that's 9, and that's 4. So it's just 9 times 4, which is 36. And then I'll multiply by 2 to give me 72. So that's the area of all 6 sides right there. And now I just have to add them all up. 54 plus 24 plus 72. So 54 plus 24 is just 78, and 78 plus 72, that's just 150. So the right answer is D, 150 centimeter square. Question number 4, they give us a factored form and it tells us which one is equivalent over here. To figure out the right answer, we just have to expand everything out. To expand, I need to multiply the first term by all three, and then the second term by all three, and then combine like terms. So let's do that over here. X times x squared is just x cubed. X times negative 3x is just negative 3x squared. And x times 2 is just 2x. Now I'll do 7 times x squared is 7x squared. 7 times negative 3x is negative 21x. And 7 times 2 is 14. Then I'll just combine my like terms. X cubed does not have a like term, so I can write that first. Negative 3x squared plus 7x squared is positive 4x squared. 2x minus 21x is negative 19x. Then I just have plus 14. So this here matches part B right there. Okay, fifth question. They give us a graph with the cost of apples. So there's the cost on the y-axis, and there's the number of points. And then they also give us cost of pears is given by this equation over here. It says that the graph shows the cost in dollars, and then the equation defines the cost in pairs. That's just what I explained over there. Which of the following statement accurately compares the cost of pounds per apple and the cost of pounds per pear at this store? Part A says apples cost 0.07 less per pound compared to pears, and then they have a couple of different options like that. We just have to figure out which one of these is true. So let's talk about 1 pound over here. So I'm going to just change this into a decimal. If I do 7 divided by 5, 7 divided by 5 is just 1.2. So this is basically my equation for my pairs over here. And if you don't know how to do this mentally, 7 divided by 5 is 1.2. I think I did that wrong as well. Let me think about that a second. It might be 1.4. You can do this with long division. Let me double check with long division because I'm pretty sure 6 divided by 5 is 1.2, so 7 divided by 5 should be 1.4. But you can do it with long division, 7, 5, if you're not allowed a calculator in this one, that is. So 5 goes 1 times, oops, 5 goes 1 times into 7. I'll also squeeze off, do it over here, more space. 7, 5, 1 times. I'm going to subtract 5 over here. I'm left with 2. I'll put a decimal point here because now 5 does not go into 2, and then I'll add a 0 here. 5 goes 4 times, so it is 1.4. So my equation is actually C equals 1.4p for the pairs. And then let's make an equation for the apples over here. So we want to look at the rise over run. For this one, we want to find 2 exact points. So my exact points are here and over here. So if I go 1, 2, 3 units to the right, so my equation for the apples, the run is 3, and then the rise is 1, 2, 3, 4. So 4 over 3, I'll say C equals to 4 over 3p. That's the one for the apples. And then if you convert 4 over 3 into a decimal value, then you should be able to do this mentally, but if not, you can just do it with long division. That's just 1.33, and it goes on forever. So now we need to compare these two over here for 1 pound. So basically 1 pound of apples is $1.33, and 1 pound of pears is $1.4. That's just what the slope tells us in this specific question. So apples is 1.33, slopes is 1.4. Let's see which statement makes sense. Apples cost approximately 0.07 less per pound than pears do. That looks kind of true. because 1.33, 1.4, the difference is 0.67. So pairs are $0.67 more expensive than apples, which means that first statement looks pretty true, but let me make sure everything else, because there might be something a bit more accurate than that. Apples cost 0.04 less per pound than pears do. That's further away than this one because 0.07 is a lot closer than that. So that's definitely false. Apples cost 0.73. That's even further away from 0.67 compared to, oh no, this says 0.07. 0.07. Maybe I did my subtraction wrong. 1.4. Let me do my subtraction over here. 1.4 minus 1.33. I'm pretty sure I did my subtraction wrong now. Just that off 3, 10. 10 minus 3 is 7. So it's 0.07, not 0.67. It's actually 0.07. So bad mental math there on my part, which means actually answer A is like really, really accurate. It's actually the correct answer in this one. I don't even have to check the rest of the answers because that one is like pretty much dead on accurate, at least compared to the rest of them. Because if you took more decimal places, you realize it's like 0.06777777 or 666666 continuously, whichever way you want to do it. But A is definitely the most accurate solution for this one. So try maybe to not do the mental math. As you can see, even I make silly mistakes with some of the mental math over here. Go to the sixth question next. Which of the following graphs is a graph of a function? So for a graph to be a function, it has to pass the vertical line test. This one fails the vertical line test because when you draw a vertical line, it should never ever cross 2 points. This one crosses 2 points. That one definitely fails. I draw a vertical line over here. That one definitely fails the vertical line test as well because it crosses 2 points over there. So that one's not true. And then third one, there's no place over here that I can draw a vertical line that will touch the graph twice. So C is definitely the right answer, but let's double check with D. With D, if I draw a vertical line right here, touches the graph at 2 points, so fails the vertical line test. So C is definitely the right answer for this question. Part B, which of the following expressions is equivalent to this equation over here? So this is testing you on factoring. Hopefully you remember your factoring methods, but if you don't, I have a lot of factoring videos on my channel. You can just go to my channel, type in factoring, and you'll see a lot of easy questions. Try to do the grade 10 math ones because these are grade 10 level. You won't have to learn grade 11 and grade 12 factoring for this test over here specifically. At least I don't think so. So if I look at this here, the first thing I can do is I can common factor out a 3 from this equation. So if I divide this entire equation by 3, I'll be left with x squared plus 2x minus 8. And now I can factor this simple trinomial here with my man method. So my m is the number at the end, which is -8. My a is the number in the middle. So to tell me two numbers, then multiply to -8 and add to 2. The two numbers are 4 and -2, because 4 times -2 is 8. 4 plus -2 is 2. My final solution will be 3 and then x plus 4, x minus 2. Again, I have a lot of factoring questions on my YouTube channel. Just type in factoring grade 10 and you'll see a lot of videos and you can go through all of them. There's a lot of good practice of all the different factoring methods you should know going into this test. So the right answer for this one is part B, because even though the brackets are switched, the signs are the same, x plus 4, x minus 2. A is not correct because the signs are not correct for that one. That's x minus 4. That's not the same as x plus 4, and x plus 2 is not the same as x minus 2. Okay, let's go to question number 8. A biologist puts an initial population of 500 bacteria into a growth plate. The population is expected to double every 4 hours. Which equation gives the expected number of bacteria after X days? So this is just an exponential equation where your main formula is A equals A naught B to the power of X divided by K. There's a couple of different other ways to write this formula, but basically A is your future value, which is represented by N in this question. A naught is always your initial value, which is 500. B is always your rate of change. In this question, the population doubles. So since the population doubles, my B is 2. If my population tripled, my B would be 3. My population quadrupled, my B would be 4. And then X is always just going to stay as X, and then we divide by the period. In this case, it doubles every 4 hours. So it's X divided by 4. Okay, but then they tell us to do this equation in days, not in hours. So this is my equation here for hours. That's why it doesn't match any of these over here. So I need to convert this to days instead of hours. So I need to figure out how many hours are there. How many days is 4 hours basically. So I know that one day is 24 hours. So X days, how many days is 4 hours basically? That's what I need to figure out. So I'm going to use cross multiplication for this. If I cross multiply here, 24 times x is 24x, and 1 times 4 is 4. And if I divide both sides by 24, I'll get x equals 4 divided by 24 can just simplify to 1 over 6. So my period, if I convert this equation into days instead of hours, it would be n equals to 500 to the power of x over, and instead of 4, I'm going to do 1 over 6 because that's the equation now in days. And now all I have to do is I have to simplify this exponent. So how do I simplify x over 1 over 6? Well, x divided by 1 over 6, I can just rewrite it as x divided by 1 over 6. You can flip that upside down and change it to a multiply. And then x times 6 is just 6x. 6x divided by 1 is just 6x. I can just rewrite this equation as 500 to the power of 6x, and that's a simplified exponent. And now this matches part B in this question over here. Which of the following values of x satisfies the equation above? So we have a quadratic equation over here. The first step to solving the quadratic equation is to move this term to the other side. So I'm going to, when I move it, it's going to become subtracting by 5. So I'll have x squared plus 5x minus 14 equals to 0. Then I need to factor this. My man method, which we did a bit earlier. Tell me two numbers that multiply to negative 14 and add to 5. It's positive 7 and negative 2. If I write this in factored form, I have x plus 7, x minus 2 equals 0. Then I just have to state the solutions here. So they're just the opposite. So x equals negative 7 and x equals positive 2. These are my two solutions to that equation there. And if I look at this, negative 7 is there, but positive 2 is not there anywhere. So the right answer is part D, negative 7, because it's just asking you for one of the solutions to this equation. Okay, let's go to question number 10 next. We have a graph given here, and they ask us to find which of the following equations could define f of x. There's a couple of different ways to do this, but they give us the x-intercept, they give us the vertex as well, and then we can always find the a value by looking at the vertex and how much graph goes to the right, the rise and run of one point is for this one. Okay, so let's start by just writing this equation in factored form. And before I write anything, the first thing I'm going to do is just calculate the a value. And the a value, if you want to know what the a value is, for a quadratic equation, we have three forms. Standard form, ax squared plus bx plus c, so that's my a value right there. Factored form, which is ax minus r, x minus s. And then we also have, so a value right there, these a values are the same. And then we also have vertex form, a x minus h squared plus k. The first thing I'm going to do from this graph is just determine the a value. The a value is just the slope from the vertex to one point to the right. So you always go one point to the right, you find the slope. So my right run over here is just one. It's always going to be one for this. And then my rise, that could change for every question, but in this case, it's one, which means my a value is just 1/1, which is 1. Now that I know that the a value is 1, I can automatically rule out options B and D because over there the a value is -1, which means that my only possible solutions are A and C. A is in standard form, C is in factored form. I'm going to write my equation out in factored form over here. So it's just going to be y equals A, which is 1, x minus r, x minus s. R and s are just your x-intercepts. So my x-intercept, my first one is 4, and then my second one is -2. So negative, negative will turn it into a positive. And then 1 times this is just x minus 4, x plus 2. This does not match this over here because the signs are the opposite as this one. So only possible solution is A over here. But if you want to expand it out, you can expand it out by FOIL. X squared plus 2x minus 4x minus 8. And then we can combine like terms. It's x squared minus 2x minus 8. And as you can see, that matches part A exactly the same. Let's go to question number 11 next. Which of the following best describes the range of this function over here? So this is a quartic function, but it's basically in transformation form, which means that we can sketch it out instantly. We don't need to do any math. It's basically very similar to a quadratic function. All even functions that have like even degree functions, I guess, should you can sketch them out instantly as long as they are in transformation form. So in order to sketch this out, this is an even function, so it's very similar to x squared. So start by just doing the vertex of the function. There's no transformation left or right, so the x value of the vertex is 0, and then the y value is moved 7 units up. So my vertex is over here at 0 and 7. And then the a value is negative, which means that the graph opens down, which means that my range for this question is just y is less than equal to 7, which is basically part C in this question. The domain would have been all real numbers, but they ask for the range in this question, not the domain. Okay, that covers that sheet, and we're actually going to get into the last sheet of this one, which has a lot of questions, the remaining 8 or 9 questions for this exam. So which of the following equations is x equals to 6 the only solution? So for this first one here, the solution is just x equals to 0 because there's nothing added or subtracted. Second one here, solution is just x equals to 6 because it's just x minus 6. There's nothing else. This one here, the solution would have been negative 6, and this one, the solution would have been positive and negative 6. So the right solution for this question is part B over there. Question number 13 gives us this equation, tells us to find f of x plus 2. So this is not going to fit on this paper here, so I'm going to actually do it on this sheet over here. So if I'm trying to find f of x plus 2, I'm just replacing all the x's with x plus 2. So I have x plus 2 square plus 3 times x plus 2 plus 1. Now I have to expand this out completely and combine like terms, and then I have to figure out which solution it matches. First things first, I'll just do the exponent first. So I'll just write out the bracket twice. So exponents first, then multiplication next. So I'll expand these two brackets and this one over here. So this is with my FOIL. This is just simple expansion. And last, I will combine like terms. X squared, 2x plus 2x plus 3x is 7x. 4 plus 6 plus 1 is 11. So that's my final solution for this one. Oh, they didn't even expand it out here. They tried to trick you, but if you look at this, the right solution is B, but it's just that starting part over there. It's non-expanded. There's only some of them that are expanded, but it's really good to know the expansion of these types of questions because they can give you an expanded answer. You will have to know how to figure this out going into the test as well, but we know that the right solution for this one is just part B. We can tell that straight away in our first step after a substitution. So we didn't need all that extra space actually for this question. Question number 14, what, if any, is a real solution to this equation over here? So I'm just trying to solve this equation. So I'll start by moving the 9 to the other side, and I'll subtract it on the other side. So 3 minus 9 is negative 6. The next thing I have to move to the other side is the square root. When I move the square root to the other side, it becomes a square. So negative 6 squared is positive 36. Then I'll move the 1 and subtract it. That becomes 35, and then I'll divide the 5 on the other side. 35 divided by 5 is 7. So right solution is just B, which is 7. Now we also have to think about restrictions for this question. Anytime you have a square root question, you also have to do restrictions to make sure that the solution is correct. And this is true for square root questions and for rational functions. I don't think we've seen a rational function, and looking at the rest of the questions, there aren't any rational function questions in the test. So you can assume maybe it's just for square root functions. We have to think about our restrictions over here. Okay, so to figure out your restrictions, you take whatever's inside the square root and make it greater than or equal to 0. Now, if I move this to the other side, it's going to be 5x has to be greater than or equal to negative 1. Then move the 5 over, so x has to be greater than or equal to negative 1 over 5. And that is true for this case as well, which means that that solution does look correct for this question over here. Although I realized I made another mistake as well in this question, because if you look at this step over here, we have a square root on this side and we have a negative number on this side, and a square root can never equal to a negative value. That's just not possible. So technically in this one, the right solution is there's no real solution, although this is a trick question, because looking at this one, I would probably think about plotting this, because this is a square root equation. And if I plot it out, the vertex is basically, or the starting point is basically -1/5 and +9. So the starting point is all the way up there and 9, and there are no reflections. So this graph will never hit 3 over there. So technically, actually, this is a trick question. There's no solution to this question. The math fails over here because this assumes that when you square the other side, it assumes that there's like a plus or minus out there, I guess. But technically speaking, this is a trick question over here. If you ever get a square root that completely covers one side and then that ever equals to a negative number, there's actually no solution to this question over here. Definitely a really hard trick question and something that even I could make a mistake with if I was not paying too much attention. Sometimes you just do the math and you see the answer and you mark the answer there. This is the kind of question that even I would accidentally get wrong in a test. But if you look at the details of that function and you sketch it out over there, you'll be able to tell that that graph will never hit a y value of 3 because it just keeps going up and the lowest point is 9. So there's no solution in that question. Number 15, if x is not equal -2 and x is not equal 3/2, what is the solution? So we do have a rational function over here. There's some restrictions there. So it looks like you do have to know restrictions for rational functions as well. So in this question here, my first step will be to cross multiply. So I have 5 times 2x minus 3 equals to x times x plus 2. Then I'll expand my brackets on both sides. So 10x minus 15 equals x squared plus 2x. I'll move all terms to the right side because it's a quadratic equation and I want to keep my x squared positive. So 2x minus 10x is -8x. And then I need to factor this with my man method. So what multiplies to -15 and adds to -8? Is that even possible, or did I make a mistake? Oh, I did make a mistake. That's a positive 15, not a -15. When I moved it, the other side should be a positive 15. My two numbers here are -3 and -5. So I have 0 equals x minus 3, x minus 5. Therefore, my two solutions are positive 3 and positive 5. So the right answer to this one is part A. All right, last 5 questions. Let's go to number 16 next. They give us two triangles. Angle J is congruent to angle P. So basically J and P are the same. Which of the following must be true in order to prove that JKL and PQR are congruent? So you could always do angle, angle, side, 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 or angle, angle, angle. Angle K equals angle Q, and angle L equals angle R. If we do angle, 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 it'll only prove that the triangles are similar. But to prove that the triangles are congruent, we need to make sure one of the sides is the exact same as the other side in the question. So this option is automatically ruled out because you can only do angle, angle, angle for similar questions. It means it has to be one of these three options over here. KL equals to QR, that would be good. And PR equals JL, that would be good. Let's see if this side, these two sides are the same. But if you have two sides, you need the angle between them to be the exact same. Because when you're doing side angle side, remember it has to be the angle between them in the same. But we know that angle J is the same as angle P, which means that if they told us these two sides are the exact same as those two sides, that would be good. But now we can cross out option B because they told us that these two sides are the same as these two sides, which doesn't matter because we don't have the angle between them. So that option is no good. Let's look at this option. JK equals PQ. So that side equals that side. And then KL equals QR. Again, that's useless because they give us these two sides are the same as these two sides, but we don't have the angles between them. So that option is off, which means the right answer has to be A, but let's double check it. Angle L equals to angle R. So these two angles are the same, which means if this angle is the same as this and this angle is the same as this, these two angles have to be the same by laws of 180 degrees of a triangle. And then they also tell us JL equals PR. So since this side is the same as this side and all angles are the same, it means that statement has to be true because when you're doing angle side, it means that any two angles must be the exact same as two angles in the other triangle. And then the corresponding side has to be the exact same as the side of the other triangle. And that's what happens in case A over there, which means that is our correct solution for that one. Let's go to question number 17 next. In question number 17, we have this equation over here. A and B are integer constants and B is positive. If the end behavior of the graph is positive for both very large negative values of x and very large positive values of x, what is true about A and B? So basically, this statement is saying that the end behavior of the graph is positive for negative and positive values of x. That just means like the graph looks like that. Basically, they're talking about the end behaviors. Both the end behaviors are positive. In the middle, it doesn't matter what's happening there. It could be U-shaped. It could be like rotate like 50,000 times and then go up. It doesn't matter. They're just talking about the end behaviors. So if the end behaviors are both positive, right? It means that the degree of the function has to be even because anytime you're going in the same direction, whether you're going up on both sides or down on both sides, that means even degree. So we know that B has to be even, which means either A or B is the correct answer. Okay, if your graph was going in opposite directions on both sides, like that means that the degree is odd. We know we have an even degree here. And then to figure out whether the A value is positive or negative, we just look at the right side of the graph. If the right side of the graph is going up, it's positive. If the right side of the graph is going down, it's negative. Since it's going up, in this case, we know that A is positive. So the right solution for this question is part B, which is A is positive and oh, B is not even actually. You want to be careful here because there's two brackets over there. So I'm going to scratch that out again because I didn't realize there's two brackets over there. I just assumed there's one bracket in the question. There's actually two brackets over here. So the exponent here is 1, and the exponent of B is what I have to find out in the question. But the overall question is even. So the overall degree is even, which means I have to add this to this. So 1 plus B has to be an even value. Now, if I add an even value, if I take B as an even value, 1 plus an even value will give me an odd value, which is not correct, which means that if I pick B as an odd value, 1 plus an odd value will give me an even value, which means B has to be odd in this equation because the total degree of this question has to be even, which means 1 plus the degree of B has to be even, which means B has to be an odd value. So the right solution for this question is A is positive and B is odd. is actually part D. So again, a bit of a trick question over there because they put this in factored form and put multiple brackets. So definitely watch out for that as well. Which of the following is equivalent to this? So we're basically converting an exponential equation into a log equation. So to convert an exponential equation to a log equation, you just start by doing the log of both sides. Then you bring down the exponent next. Then you divide both sides by the log that's attached to the x. On this side, it cancels out, so I just have 5x. And on this side, we can simplify this here with our change of base rule. It's just going to be log 2, 7. The log on the bottom just goes the base right there. Then last step, we just divide the 5 on the other side. So x equals to log base 2, 7 divided by 5, which the right answer for this one is part B. Okay, if x is greater than 0 and y is greater than 0, which of the following expressions is equivalent to this over here? Probably automatically rule out A, but this question is asking us to rationalize most probably. Not 100%, but most probably if I see something with square roots being added or subtracted, I always rationalize. That usually gives me the correct answer. So rationalize, I'm going to multiply the top by root of x plus root of y, basically the same as the bottom, and bottom I'm going to multiply by the same thing, root of x plus root of y. When I'm rationalizing, I'll never ever expand that over there. I'll only expand everything that has the square roots. So I'm just going to write the top in factored form, and now I'm going to expand the bottom. So root x times root x is x. Root x times root y is root xy. Negative root y times root x is negative root xy. And negative root y times root y is negative y. Can combine like terms in the bottom. These two middle terms will always cancel each other out when you're rationalizing. So I just have x minus y times root of x plus root of y divided by x minus y. You can cancel these out, and I'm just left with root x plus root y, which is part C right there among the solutions. And the last question over here, triangle ABC is a right, angle C is a right angle. So let's draw that out. Let's C is a right angle. Cos A is 5/8. Find the value of cos B. So I'm just going to put A here, and I'll pick B over here. So cos A is 5/8. So A is right there. So cos of A is adjacent. Cos is adjacent over hypotenuse. The adjacent is 5 and the hypotenuse is 8. I can find the opposite side using my Pythagorean theorem. So A squared plus B squared equals C squared. Trying to find A squared there. B is just 5. I squared equals 8 squared. A squared plus 25 equals 64. I'll subtract that on the other side. So that's 39. And then I'll square root. So A equals square root 39. That side there is square root 39. And then I need to find cos B. So cos B, that's this angle here. It's just the adjacent, which is root 39 divided by the hypotenuse, which is 8. So right solution, this question here is part C. All right, that's the last question over there. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. If you want me to make more sample videos, let me know in the comments and I'll make a couple more sample tests like this. I've already published a few for the algebra, for the arithmetic and for the quantitative reasoning and statistics, and I do plan on posting more for all of them, but let me know in the comments. That way I know that people find this useful and they want more tests like this. Thank you for watching and have a wonderful day.